You're watching a Channel 98 NBISD TV production.
Hey, welcome to That Geometry Show. I'm your host, Kevin Corpy, as always. And today is lesson 15, which kind of brings us to about the halfway point of this season. And so appropriately, we have something kind of unique that we're going to do today. We're going to be reviewing a lot of the concepts that we've already covered this year. Now, as you probably know, to graduate from high school in the state of Texas, you have to pass a standardized test called the Texas Assessment of Knowledge and Skills, or the TAKS for short. Now, the TAKS test has lots of mathematics questions on it, and lots of those are going to be geometry questions. So what I'm going to do today is go back and review the concepts that we've already covered this year in the TAKS format, so the types of questions that you'll actually see on the TAKS test. Let's get going. Okay, today lesson 15 doesn't really correspond with any particular chapter in your textbook. It's the TAKS review. We're going to be reviewing all the concepts. Now, the two most important geometric objectives on the TAKS test are Objective 6 and Objective 7. So we're going to take them in order. Objective 6, here's what it says. A student will demonstrate an understanding of geometric relationships and spatial reasoning. That's geometry right there. Okay, so different types of problems that you're going to see are going to require a variety of techniques. And you just want to make sure that you read the questions very carefully. You draw diagrams if you need to. You clearly label the diagrams that are given, and you make sure that you answer the questions. Okay, let's look at a particular example that is TAKS worthy. Here's the problem. It says, in triangle ABC below, okay, and again we have a triangle labeled with 3 capital letters, find the measures of angle 1 and angle 2. So how are we going to set out to do this problem? They're giving us the diagram. Well, we have to notice what we have. We have a triangle, and the two angles we're looking for are outside the triangle, or their exterior angles. Okay? Now notice that these two lines also intersect right here. So I have angle C right here the way it's labeled, and angle 2. Those are opposite from each other. Those are called vertical angles, if you remember. Let's review vertical angles briefly here. Vertical angles are formed by the intersection of two lines. Vertical angles are always congruent. That means they have the same measure, remember. The adjacent angles formed by the intersection of two lines are always supplementary, which means they add up to 180 degrees. Okay? So let's look at this diagram and see how that'll help us. Notice in this triangle I have angle A is 60 and angle B is 40. And so we remember that the sum of all the angles in a triangle has to add to 180. So this angle right here, angle ACB, or the measure of angle ACB, has to be what we need to get to 180. So 60 plus 40 is 100. To get to 180, that means that this angle must be 80 degrees. Okay? The sum of the interior angles of any triangle has to equal 180. Well, now that I know that the measure of angle ACB is 80 degrees, what is opposite it? Angle 1. Two intersecting lines form vertical angles, so vertical angles are congruent. So if this angle here is 80 degrees, then its vertical angle, namely angle 1, must also be 80 degrees. So let's go ahead and fill in what I have here. That's 80 degrees, and the measure of angle 1, because it's a vertical angle again, is also 80 degrees. So how is that going to help us find the measure of angle 2? Well, remember that angle 1 and angle 2, since they are on a straight line, form a linear pair, and all linear pairs are supplementary, so they all add to 180. So we could say then here that the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. Well, since we know the measure of angle 1 is 80, I can substitute that in. So 80 degrees plus the measure of angle 2 equals 180 degrees. And we've created a little algebraic problem. So all we have to do to solve for the measure of angle 2 is to subtract 80 degrees from both sides, and we get that the measure of angle 2 is equal to 180 minus 80, or 100 degrees. Okay? And we've answered the question. So there they are. So it was a couple of steps involved in finding the measure of angle 2. Now, let's review another concept from a previous episode. Now, there was another way to find the measure of angle 2. If you remember, angle 2 is called an exterior angle. And we had a little theorem that said the sum of, or the measure of an exterior angle is equal to the sum of the two remote interior angles. Remote meaning further away, and interior meaning on the inside. So if we remembered that theorem, we could say that the measure of angle 2 is equal to the measure of angle A plus the measure of angle B. And since we know what those two are, that's going to be 60 degrees plus 40 degrees, and we get that it's 100 degrees. Okay, so if you remember the theorem, you can get there directly a little bit more quickly. But even if you don't remember that theorem, you can look at the diagram and you can work your way towards finding that measure by knowing vertical angles and then supplementary angles. It works out just as well. Okay. Another example here. This one has no diagram, okay? Let's read carefully. If angle A is the supplement of angle B and angle B is the supplement of angle C, then what is the relationship between the measures of angle A and angle C? Well, we could draw a triangle here and label them A, B, and C, but it's really not necessary. This is careful reading and trying to remember what the definitions mean. Okay? If angle A is the supplement of angle B, what does it mean to be supplementary angles? That means that the two angles add to 180 degrees. So I can say the measure of angle A plus the measure of angle B has to equal 180 degrees. I know that. It also says that the measure of angle B is the supplement of C. So B and C are supplementary angles, so the measure of angle B plus the measure of angle C also has to equal 180 degrees. Now I'm trying to relate A to C. Well, I have one equation with A and one equation with C, and basically angle B, or 180 degrees, is the middleman. So here's what I can do. Since they're both equal to 180, both equations, then I can set them equal to each other. So I'll say the measure of angle A plus the measure of angle B has to equal the measure of angle B plus the measure of angle C. So we're creating just a little bit of algebraic equation here. Now, if I subtract the measure of angle B from both sides, it'll cancel here and it'll cancel there, making a zero pair. So I end up with the measure of angle A equaling the measure of angle C. And that's the relationship. They're actually the exact same size, so we could say that angle A is congruent to angle C. That's another way to say they have the same measures. Okay? And that's basically doesn't really matter what the actual measures are. We just know the relationship between them. Okay? Now, the next one in Objective 6 is going to involve Pythagorean theorem, which you had in algebra class. It's resurfaced here in geometry. It's a pretty important theorem. And you're going to have to look for patterns in right triangles. Now, here's a diagram of right triangle. And remember, the longest side is opposite the right angle, and it's called the hypotenuse. And the two shorter legs are the legs, and we call them A and B. Now, here's the famous Pythagorean theorem. A squared plus B squared, the two shorter legs squared, when you add them together, equals the hypotenuse, the longest side squared. Let's say you forgot that formula. You're going to be lucky because on the TAKS test, you're going to be given a formula that looks something like this. And you'll be able to scroll down and see that the Pythagorean theorem is actually given right here. So you won't have to memorize the theorem, but you are going to have to remember what the actual letters are, A squared, B squared, and C squared. It's not going to tell you that C is hypotenuse. So you have to at least remember that. Okay? Now remember in a previous episode we talked about a Pythagorean triple. If you know your Pythagorean triples, you can answer questions a little bit more quickly, okay, or a little bit more easily. Remember, a Pythagorean triple is basically a set of three whole numbers, okay, not fractions, not radicals, that satisfy the Pythagorean theorem. The smallest one, remember, was the pair 3, 4, 5. That's a pretty common one. Another Pythagorean triple that comes up quite a bit is 5, 12, 13. And another one that's pretty common is 7, 24, 25. Okay? So all of these are Pythagorean triples. If you take any Pythagorean triple, and here's what's nice about memorizing these, you can multiply each of the numbers, say by any number, call it a 2 in this case, and you're going to get another Pythagorean triple. So 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So the pairing 6, 8, 10 is another Pythagorean triple. If I proceed all the way through here with the next one, 5 times 2, 10, 12 times 2 is 24, 26. That's another Pythagorean triple. And I can do the same thing down here on the bottom. Multiplying everything through by 2, I get 14, 48, 50. And multiplying by 2 is just arbitrary. I can multiply by any other whole number to create a new Pythagorean triple. So quite expandable. Now, why would you want to memorize those? Well, that's a good question. Let's look at this example here. Here's an example you might find on the TAKS test. And this calculator here just means that it is a calculator active question. You're going to be allowed to use your TI-83 on the actual TAKS exam. So having it is one thing, knowing how to use it and when to use it is something altogether different. Now, we can answer this question without the calculator. It says find the length of side B right here in the right triangle shown below. Well, notice I have this side is 10 and this side is 26. If you recognize that as part of a Pythagorean triple, you can answer the question. Well, you probably didn't remember the 10, 24, 26 that I just generated, but you might have remembered the 5, 12, 13. So if you can write this side 10 as 5 times something, and this 26, the longest side, as 13 times something, then this Pythagorean triple would be a dilation here in this case. It would be the Pythagorean triple that we know times 2. So the Pythagorean triple here would be a 5, this would be a 12, and this would be a 13. Now notice that every side length, all three of them, is increased in proportion, the same proportion. In this case, 5 times 2 equals 10, and 13 times 2 equals 26. So the missing side must be 12 times 2, or 24. Now granted, that requires you to know the Pythagorean triple and to have a little bit of insight into recognizing it. So what happens if you don't know that? Well, you can go to your formula chart or pull out of your head the handy-dandy Pythagorean theorem itself, which says that a squared plus b squared equals c squared. And just remember that c is the hypotenuse. It's always the longest side opposite the largest angle. Now, if we carefully plug in, it doesn't matter which side. I guess in this case I can call a 10. It does matter because we're trying to find b. So 10 squared plus b squared, my unknown, equals c squared, 26 squared. And so now with the help of the calculator, you can square both sides. 10 squared is 100, plus b squared equals 26 squared is 676. Now I need to solve for b squared by subtracting 100 from both sides, and I get b squared is going to equal 576. Now, how do you solve for b in this case? You have to take the square root of both sides, and there's a button on your calculator for that. So b is going to be plus or minus, you have to remember to add that, the square root of 576, which is going to give us 24. Now, do we really want the negative version of 24 in this case? The answer is no, because we're talking about a side length. So positive 24 would be the answer. Okay? So Pythagorean theorem, he's going to be on the TAKS test. Whether you know your Pythagorean triples or not, you always have the actual formula that's given to you that you can fall back on. Okay. Another thing that's going to be on Objective 6 are the transformations. And we talked about transformations in an earlier program. We basically had some rigid transformations. And remember, a rigid transformation is one that does not change the shape of the object. It remains rigid. Another name for the rigid transformation was an isometry. An isometry was a rigid transformation. Okay? We had three types. We had translations. That was one type. Translations. We had rotations around a fixed point. And we had reflections across a given line. Now the TAKS test is probably going to deal with transformations, these rigid transformations on a coordinate plane. And so here's a nice little thing to remember. When figures are transformed, we use the prime notation or the hash notation to denote the image of the original point. So if I start with point P and I translate it, rotate it, or reflect it, I'm going to get a new point. That's called the image of the original point, and we denote it as P prime. Let me show you exactly what I mean. The graph of triangle ABC is shown below here. We want to find the coordinates of our new triangle, A prime, B prime, C prime, which is going to be the image of the original triangle when I reflect it across the y-axis and I translate it, which remember means to shift 2 units up. So here's what I need to do. I need to carefully plot my new points. So let's go ahead and do the reflection first. Here's the y-axis. Remember, it's the vertical axis. I need to take this point A and reflect it across. Well, this point A is at the point 4, 1. So when I reflect it across the y-axis, it's going to be the same distance away from the y-axis, 4 units, but on the other side. So that should be at the point -4, 1. So that's my new A point, but that's just with the reflection. And then I can do the same thing with the other 2 points. B is currently at the point 5, 4. If I reflect it across, it's going to be 5 units away, but it's going to be on the other side now. So -5, 4, which is right there, 1, 2, 3, 4. And if I take C, which is currently at the point 8, 1, and reflect it across the y-axis, it'll be 8 units away on the other side and still at the same height or y value. So this, I'm going to dot it in here, is going to be my first image from the reflection. Now I'm not going to name the points there because that's not my final answer. Because now I need to take that graph and translate it or shift it 2 units up. So you could think of these as a sequence of transformations. Well, that's pretty easy to do. I just take each of these points and move them up 2. So this point here would go up 2. And that's going to be where my new point C, which reflected over and went up. So I'm going to call that C prime. This point here, which was my B value, now is up 2. He's there, so that's B prime. And this point here, A, is going to now move up 2, and it's right there, and so that's A prime. And so my final graph, now connecting the dots, is going to look like that. And so that's my new triangle, A prime, B prime, C prime. Well, did we answer the question? Drawing, it's one thing. It says we need to find the coordinates. So now that we have it drawn, though, it makes it real easy just to look at our coordinate grid and write the coordinates. Okay? So A prime is at the point -4, 3, -4, 3. And we typically don't write colons or anything. We just put the point or the letter of the point, and then the point follows in parentheses. Point B is going to be at the point 1, 2, 3, 4, 5, 6. Okay? You can count. Left 5. Up 6, and then point C is going to be left 8 and up 3. So -8, up 3 is the positive direction. So those are the new coordinates of our image, of our transform graph with the prime notation. Oh man, those tax questions can be quite taxing. Yeah, I need a break. How about you? Let's watch some of those public service announcements and we'll get right back to it.
I smoked weed and nobody died. I didn't get into a car accident. I didn't OD on heroin the next day. Nothing happened. We sat on Pete's couch for 11 hours. Now what's going to happen on Pete's couch? Nothing. You have a better shot at dying out there in the real world. Driving hard to the rim, ice skating with a girl. Now you want to keep yourself alive, you go over to Pete, sit on his couch till you're 86. Safest thing in the world. Me? I'll take my chances out there. Call me reckless.
Bad people, the gang members in the neighborhood. My brother, he wouldn't be happy at all if I was to tell him I was going to drop out of school. He would not approve of that, because then that's going to be 2 of us not handling our business.
Me and my friends are close and we all believe in each other. I know they could graduate, even if it takes them longer than the 4 years.
We have classes together, so
we study together, we help each other with our homework.
Realized we messed up in the past.
Failed a couple classes before, not doing as much work as I should be doing. My 2 best friends, they keep me working hard.
All right, hope you enjoyed those. Welcome back. Let's get right back to the tax math. You might be asked to do something with a rotation, and those are a little more interesting. Here we have the graph of RST. We want to find the coordinates of S prime if triangle RST is rotated 90 degrees clockwise around point T. Okay, so here's point T right here. I want to rotate clockwise, that's important, 90 degrees, so I'm rotating it this way. I'm just going to draw a little arrow up here to help me remember that. And this is my pivot point, basically. Well, I need to figure out where this point goes, point S. So, if this line here is rotated 90 degrees, the new line segment basically is going to be TS prime. That's my new line segment, and it should be perpendicular. If you remember, perpendicular has a symbol like this. It should be perpendicular to my original segment, TS. Okay, so how is that going to help us find it? Well, let's go ahead and find the slope, which we called M, of the line segment TS. Okay, so slope, that's another thing that if you forget the formula is on your formula sheet. It's going to be right here, slope of a line. It's going to be right here. It's M, which is, remember the French verb montar, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, that's just the change of your y values over the change in your x values. So let's find those 2 increments. We need to go ahead and label the points here first. This is the point 3, 2, point T, and then point S is going to be at the point 8, 7. So it helps to label those. Now that I have my 2 points, I can use my formula. It's going to be M, and I'm going to come down here for a little more room, the change in my y value, so 7 minus 2, this one minus this one, over the corresponding change in the x value, so 8 minus 3.